Okay, example 2, it's going to be the same thing. We're going to go ahead and switch our numbers again. Right here, they gave us that y equals x line. That dotted line is the line of reflection. So I'm going to go through and I'm going to go ahead and switch all these. I'm going to kind of be funny about this and just go through and do it one at a time like this. That way I don't have to concentrate that much on it. If you'll notice what I'm doing, I'm just basically switching the numbers. That's it. You can see it right there. How I'm doing this. And now what I'm going to do is I'm going to go plot every single one of these points. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That's one of them. Now I'm going to go do -4, -4. -4, 1, 2, 3, 4. Makes sense that it's on the line. 0, -2. 0, -2 is going to be right here. 2, -1 is going to be right here. 2, -1. If I can do it. It's weird writing points on this stupid digital pen. Why doesn't it just let me do it without being weird? There we go. 2, -1, then 4, 0. And then I have 6, 1. And then I have 8, 2. And then you'll notice right here, this is your line. I'm going to try to connect it as best as I can. Put the little arrows on there, y'all. It's not a line without the arrows. And there you have it. That's your graphed inverse function. It's not that big of a deal. There is a test you have to do. Basically, with x's, when it's all said and done, you can only have an x going to like one time. So you see how this -6 is here? It's only here one time. That's a good thing. If you had -6 repeated, it would end up being weird and not a function, and I'll show you that on another example. But let's go ahead and go down to here. And let's talk about this. So this is the same thing. We're going to go ahead and switch this out. Watch as I do this. I'm going to switch it. 7, 2, -1, -2, -1, 2, 7, -1, -2, -3, -4. I'll get the idea. It's kind of boring. And then that. Okay. So now this is technically the inverse. And so what you have to look for to know if it's a function or not, and for those who don't remember what a function is, it basically has to pass the vertical line test where you can draw a graph on there, and if you draw a vertical line like this and it only passes one time through each place, then you have yourself a function. That's the way to do it with graphics. The other way to do it is to check for your x's. Do you have x's that are going to different, that are the same or not? So I have a 7, a 2, a -1, a -2. Uh-oh, -1, a 2, and a 7. So when my x's repeat, more than likely it's not going to be a function. Okay? So, and we'll see that when we graph this. So let's go ahead and graph this thing. They put our little line of reflection up for us, y equals x. 7, -7, 1, 2, 3. I'm going to push pause and do these so it doesn't make up the, doesn't take too long on the video. Okay, I put up what I think are the right points. It's kind of weird. 1, 2, 3, 4, 5, 6, whatever. If I made a mistake on this, it's not the end of the world. As you can tell, I'm kind of tired of graphing this stuff. When it's all said and done, you're going to end up with a weird shape like this. Granted, it should look more like this, but I can't draw. You can test if it's a function by doing the vertical line test. You ready? If it passes through more than once, boom, not a function. It is not technically a function at this point by definition of this. So is the inverse a function on this one? The answer is no, it is not, because it does not pass. You can see that the x's repeat more than once, and it goes through like that. So that's how you tell that for this one. Going up here, is this a function, the inverse one? The answer is yes, and it's because the x's don't repeat. You see how the x's do not repeat? And then if I were to draw the lines, they'd only go through one time. So that's example 2 and 3.